Hi madam, my name is Muhammad Safwan bin Zobri. My matrix number is 01DKA19F1156. Okay, today I will talk about my individual presentation. Okay, first we go to definition of shear strength. Shear strength is a term used in a soil mechanics to describe the magnitude of the shear stress that a soil can sustain. The shear resistance of soil is a result of friction and interlocking of particles and possibly condensation and bonding at particle contacts. Due to interlocking, particulate material may expand or contract in volume as it is subject to shear strains. If soil expands its volume, the density of particles will decrease and the strength will decrease in this case. The peak strength would be followed by a reduce of shear stress. The shear stress strain relationship levels of when the material stop expanding of contracting and when it's in the particle bonds are broken. The theoretical state at which the shear stress and density remain constant while the shear strain increase may be called the critical state, steady state, and residual strength. Next, a critical states line separate the dilatant and contractive state for soil. The volume, charge behavior, and interparticle friction depends on the density of the particle, the intergranular contact force, and to a somewhat lesser extent other factors such as the rates of shearing and the direction of the shear stress. The average normal intergranular contact force per unit area is called the effective stress. If water is not allowed in or out of the soil, the stress part is called an undrained stress part. During undrained shear, if the particles are surrounded by a nearly incompressible fluid such as water, then the density of the particle cannot change without drainage, but the water pressure and effect stress will change. On the other hand, if the fluid are allowed to freely drain out of the pore, then the pore pressure will remain constant and the test part is called a drain stress part. The soil is free to dilate or contact during shear if the soil is drained. In reality, soil is particularly drained somewhere between the perfectly undrained and drained idealized condition. The shear strength of soil depends on the effective stress, the drainage conditions, the density of the particles, the rate of strain, and the direction of the strain. Okay, next is use of shear stress. Okay, one must understand the nature of shear resistance in order to analyze soil stability problem such as A. Bearing capacity, B. Slope stability, C. Lateral earth pressure on a retaining structure. Okay, this is an example of picture soil generally fail in shear and at failure shear stress along the failure surface mobilize shear resistance and reach the shear strength. This example of the bearing capacity and slope of stability and a retaining structure. Okay, this is example. Okay, shear stress is a very important property of soil The concept is used by geotechnical engineers in estimating the bearing capacity of foundation and assessing the stability of retaining walls, slope and embankment, and the design and construction of highway and airfield pavement. The shear strength of a soil can be regarded as its intrinsic capacity to resist failure when force acts on the soil mass. The strength is a function of the types as well as the psychochemical makeup of the soil. This chapter explores the strength theory that are used in geotechnical engineering and which derive essentially from the classical theory of elasticity and plasticity. Such theory is usually modified when used by soil engineers in recognition of the discrete and multi-phase nature of soil deposit. It is important, therefore, to understand some of the fundamental concepts by hypothesis of continuum mechanics to be able to appreciate the limitation and applicability of strength theories in geotechnical engineering. Okay, next we go to Moore column failure criterion. The Moore column criterion is the most common failure criterion encountered in geotechnical engineering. Many geotechnical analysis methods and programs require use of this strength model. The Moore column criterion describes a linear relationship between normal and shear stress, or maximum and minimum principal stress at failure. This is equation for the direct shear formula of the criterion is given by equation 1, and the Moore column criterion for terrestrial data is given by equation 2. Okay, this is a Moore column failure criterion in terms of total stress and Moore column failure criterion in terms of effective stress. Lastly, in geotechnical engineering, it is used to define shear stress of soil and rock at different effective stress. The Moore column MC failure criterion is a set of linear equations in principal stress space describing the condition for which an isotropic material will fail with any effect from the intermediate principal stress being neglected. Okay, that's all from me. Thank you.